Now we consider the indeterminate form infinity minus infinity. These two should be reduced to 0 over 0 or infinity over infinity type in order to apply L'Hopital's rule. Let's look at two examples. The limit of 1 over x minus 1 over e to the x minus 1 as x tends to 0. As x tends to 0, 1 over x tends to infinity. This is from the right side, x is positive, so 1 over x will tend to positive infinity. And on this side, we have e to the x minus 1. This is the graph of e to the x. And it has a y-intercept 1. When x is to the right of 0, x tends to 0 from the right. E to the x is higher than 1. So this quantity is positive. And that too tends to infinity, 1 over that, because denominator is getting smaller and smaller. And they are subtracted, so it's infinity minus infinity type. And this, we can reduce this to either 0 over 0 or infinity over infinity by combining these using common denominator. So this is equal to the limit as x tends to 0 from the right. The common denominator is x times e to the x minus 1. For the first, we have a numerator e to the x minus 1, because we have to multiply both numerator and denominator of the first ratio by e to the x minus 1. The second one is multiplied by x over x. So we get x times 1, which is x. Now, it's in the ratio form. Let's see if it's 0 over 0 or infinity over infinity. As x goes to 0 from the right, e to the 0 goes to 1. So 1, so that whole thing will tend to 1 minus 1 minus this x tends to 0, which is 0. In the denominator, x tends to 0, e to the x tends to 1, and you have minus 1, so it's 0 times 0, and that too tends to 0, so we have 0 over 0 type. Therefore, L'Hopital's rule applies. So by L'Hopital's rule, we take the limit as x tends to 0 from the right of the ratio of the derivatives. Derivative of e to the x is e to the x minus derivative of 1 is 0 minus derivative of x is 1. In the denominator, we have a product, so we use the product rule. Derivative of the first function is 1 times e to the x minus 1 plus the first function x times derivative of e to the x minus 1, which is e to the x minus 0. And now simplify and try again. So this is equal to the limit as x goes to 0 from the right of e to the x minus 1. In the denominator, I have 1 times e to the x is e to the x minus 1 times 1 plus x times e to the x. Now let's try again. As x goes to 0, the numerator tends to e to the 0 minus 1, which is 1 minus 1, which is 0. Denominator tends to e to the 0, which is 1 minus 1, plus 0 times e to the 0. And when we simplify this, 1 minus 1 is 0, 0, so it's 0 over 0 again. So that means we can apply L'Hopital's rule again. Sometimes you have to apply L'Hopital's rule more than once until we no longer have 0 over 0 or infinity over infinity, until we can find the limit in elementary way. Derivative of the numerator is just e to the x, because derivative of minus 1 is 0. Now in the denominator, derivative of e to the x is e to the x minus derivative of 1, which is 0, plus the product rule for x e to the x, which is derivative of x, which is 1 times e to the x, plus x times derivative of e to the x, which is e to the x. And now try again. Let x tend to 0. Numerator goes to e to the 0, which is 1. In denominator, e to the x plus e to the x, you can write as 2e to the x. And that tends to 2 e to the 0, which is 2 times 1. And x times e to the x will tend to 0 times e to the 0, which is 0. So the whole denominator would tend to 2, so the limit is 1/2. Now let's look at another example. Here we have a limit of 1 over x minus 1 over arctangent of x, or inverse tangent of x, and x tends to 0 from the right. So 1 over x will go to infinity, and then minus the limit of 1 over arctangent of x. For arctangent, we should look at the graph of arctangent. It looks like this. It has a horizontal asymptote at pi over 2, and another one at minus pi over 2. But here x tends to 0 from the right, so x is tending to 0 in this direction, and that makes arctangent or tangent inverse to go to 0, and it is positive on that side, so 1 over positive 0 is positive infinity. So this is the case of infinity minus infinity indeterminate form. So we try to reduce it to 0 over 0 or infinity over infinity by doing a little bit of algebra. And then once you do that, we use L'Hopital's rule, because L'Hopital's rule only applies directly to 0 over 0 or infinity over infinity indeterminate form. The common denominator is x times tangent inverse of x, and for the first numerator we get tangent inverse of x. For the second one we get x. Now we try what's the limit of the numerator as x tends to 0. That is inverse tangent of 0, which is 0 minus 0, so that's 0. Denominator tends to 0, x tends to 0 times arctangent of 0 is 0. So this is a 0 over 0 type. So therefore, L'Hopital's rule is applicable. So here's the limit of, take the derivative of the numerator over derivative of the denominator. Derivative of arctangent is 1 over 1 plus x squared. that's derivative of arctangent of x, minus derivative of x is 1. In the denominator, this is a product rule, derivative of x is 1 times arctangent of x plus x times derivative of arctangent of x, which is 1 over 1 plus x squared. Before you try finding the limits of numerator and denominator to see whether it's still 0 over 0 or we can find the final answer here, let's do some algebra to this one. So we can multiply both numerator and denominator by 1 plus x squared. And then we get the limit as x tends to 0 from the right. In the numerator, when you multiply 1 plus x squared by 1 over that, you get 1. And then minus 1 times 1 plus x squared is just 1 plus x squared. In the denominator, this 1 plus x squared is multiplied by arctangent, so you get 1 plus x squared times the inverse tangent of x plus x times 1 over 1 plus x squared by 1 plus x squared. The 1 plus x squares cancel, you just get x here. Now let's try sending x to 0. As x tends to 0, the numerator tends to 1 minus 1 minus 0, which is 0. Denominator tends to 1 plus 0 times 0 plus 0, that too is 0. Arctangent of 0 is 0. 1 plus 0 is 1 times that is 0 plus 0 is 0. So it's still 0 over 0 form. Let's simplify that numerator and then apply LHopital's rule again. So this is the limit of minus x squared over 1 plus x squared times inverse tangent of x plus x. So this is 0 over 0 type. So for that, LHopital's rule is applicable, and this is as x tends to 0 from the right. And now we take the derivative of the numerator, which is minus 2x. In the denominator, I have to use the product rule for 1 plus x squared times the inverse tangent of x. Derivative of the first function is 2x times the second function, inverse tangent of x, plus the first function, 1 plus x squared, times derivative of the inverse tangent x, which is 1 over 1 plus x squared, and then plus derivative of x, which is 1. So now you can tell this will give you a 1, and then there is a plus 1 there. And now let's see, as x goes to 0, 2x goes to 0, minus 0 is 0, so the numerator goes to 0. In the denominator, x times tangent x goes to 0, but there is still a 2. So what you get is 0 divided by 2, which gives you the answer to this limit, and that is 0. So now we had two examples of the indeterminate form, infinity minus infinity. So it just means do a little bit of algebra to turn it into a 0 over 0 form or infinity over infinity form, and then you can apply LHopital's rule directly. There will be other types of indeterminate forms that we consider in other videos in this lesson.